this probably will be a little bit of a review of grade 11. So I'll go kind of fast through this. The only difference will be is we're going to solve in degrees, and then we're going to solve again for radians. So the first examples are, A is an example on the unit circle that you should have memorized. So you can do the reverse hand trick however you want, but where is your y value or your sine theta equal to 1/2? And that would be the family of 30s. So your reference angle would be 30 degrees. If we're doing radians, that would be the pi over 6. So my answer then for Roman numeral 1 would be the two quadrants where sine is positive, which would be 30 degrees and 150 degrees. In Roman numeral 2 in radians, that would be pi over 6 and, yes, 5 pi over 6. Okay, so for the next one, you need a calculator. So again, when you use your calculator, make sure you have your calculator in the right mode. So if we're going to do this in degrees, it's not as easy as the last example where we can go between. So we're going to finish the question totally in degrees, and then we'll finish the question totally in radians. Because you're not supposed to round before the final answer. So I'm going to make sure my mode is in degrees. When we do inverse cos to figure this out, ignore the sign. So my reference angle then would be, we're going to do degrees to the nearest tenth. So approximately 72.5 degrees. So where is sine, cosine positive? That would be in the first and the fourth quadrant. So then theta would be approximately 72.5 degrees. And then we are going to take that answer and subtract from 360, and we get 287.5 degrees. So now we're going to redo this again and get the reference angle in radians. So we got to go to our mode, change it to radians, do inverse cos of 0.3, and we get 1.2661. We're going to do correct to 3. I'm going to write 4, which means theta is approximately 1.2661. And to get the fourth quadrant answer, we would take 2 pi and subtract your previous answer. So try that on your calculator. 5.017, I guess O. All right. So now tan theta is √3. That is a memorized value on the unit circle, so no calculator. So that would be your family of 60s. So the reference end would be 60 or pi over 3. So for Roman numeral 1 in degrees, that would be theta equals 60 degrees. And then, of course, tan has that unique characteristic where the angles are 180 degrees or pi from each other. So 240 degrees. And if it's in radians, it would be pi over 3. And then if I add pi to that, I would get 4 pi over 3. All right. So now we're going to do some one-step equations. Some of you might be exposed to this from last semester. So here's kind of the algorithm of how you should approach this. So you need to first isolate your trig function. For instance, 2 sine theta plus 1 equals 0 is the same thing that you're solving algebraically, like 2x plus 1 equals 0. You'd move the 1 over, divide by 2. Do you see you would get x equals -1/2? So I'm going to say this is similar to that. Don't introduce a variable, though. So if I isolate this, I move the 1 over, divide by 2, I get sine theta equals -1/2. So then we have to find the reference angle. So exact value. So this would be now we're doing this in radians here. So this would be a pi over 6. So my reference angle is pi over 6. I'm not saying my answer is pi over 6. I'm saying it's in the pi over 6 family. So now because sine is negative, you need to come up with the two quadrants that are the pi over 6 family that sign is negative. So theta equals, so pi over 6 family would be the third and fourth quadrant. So that would be 7 pi over 6 and 11 pi over 6. All right. Moving on. So these are exact solutions, so no calculator. So sine theta is 0, and that is where the y value is 0, and that's in 3 spots. Notice my domain is in radians, and it's including both 0 and 2 pi. So theta would be 0, pi, 2 pi. Where is cos 0? Well, cos is 0 where x is 0 at the top and the bottom. So that would be pi over 2 and 3 pi over 2. Where is tan 0? That would be where sine is 0 or where your y values are 0. So that would be the same answer as A, 0, pi, 2 pi. Secant is 2, so what I would do is in the first step change this to the reciprocal function cos theta. So that would be cos theta equals a half. So my reference angle would be where cos is a half. Again, this is in radians, so this would be a pi over 3 family. So then we have to come up with the two quadrants where cos or secant, they're both reciprocals of each other, are positive. So that would be the first quadrant, which would be pi over 3, and the fourth quadrant, which would be 5 pi over 3. First thing you should do is to change cosecant theta equals -1 into sine theta and reciprocate -1, which it will still be -1. And so when y is -1, that is something that's on the axes. And so if you think about that, where is the y value -1? It's only in that one spot between 0 and 2 pi. And so theta would be 3 pi over 2. All right. So again, this is on a non-calculator part. Solve for the trig ratio, cos theta equals 3. And you might say, well, wait a second, this is not in the unit circle. It won't be. But you should know, and this is something if they ever ask you on the provincial exam, this would be no solution. And why is it no solution? Well, because of the unit circle, do you see my cos and my sine? The highest it can go for sine is between -1 and 1, and for cosine, the lowest it can go is between -1 and 1. So if they ever ask you, why is there no solution, your justification is because cosine theta has to be between 1 and -1. I'll just say since. And then you can replace that with sine theta. So is there a limitation on tan theta? No, tan theta can be anything. Of course, it can't have it, you get an undefined region in tan, so you got to watch out for that. But if any time your trig ratio is greater than 1 or less than -1 for sine and cosine, there is no solution possible. Okay, so it's saying use exact solutions where possible, otherwise round to 3 decimal places. Again, rounding to 3 decimal places, we're going to do 4 and truncate, which means cut off. So first things first, get cos theta by itself, so that would be equal to -1 over 2. This is an exact value, so we're going to come up with our reference angle, which that would be, it does say in radians here, so that means it would be the pi over 3 family. So then where is cos negative? Well, that would be the second quadrant and the third quadrant. So that would be 2 pi over 3 and 4 pi over 3. Okay, so maybe you want to pause this and try these. Otherwise, I'll keep going. So I'm going to move 7 tan over. So I'll get -4 tan theta. And I move the 5 over, so I get -1. So then that means I get tan theta equals +1/4. That is not on the unit circle, so I got to grab my calculator, make sure my mode is in radians. And the first things first is I'm going to do my reference angle. Again, don't put a sign in, although positive it won't matter. So inverse tan of 1/4 is approximately 0.2449. Where is tan positive? Well, it'll be where your reference angle is, so 0.2449, that's the first quadrant. And what is kind of the nice characteristic of pi? Well, you just have to add, oh sorry, the nice characteristic of tan, you just have to add pi to it. So 3.3865. If you want, you can go even more. So there's my two answers for tan in my first and my third quadrant. Okay, so next one. Cosecant theta is equal to -2/√3. That means sine theta is equal to -√3/2. This is an exact value on your unit circle, so no calculators. So which family would this be? This would be the pi/3 family. But where is sine negative? That would be third and fourth quadrant. So that would be 4pi/3 and 5pi/3. Okay, next one. Cotangent theta equals 3/2. Can't do that on the unit circle. So first off, I got to change this to tan. So tan equals 2/3. Now I'm going to go to my calculator. Notice the calculator doesn't have any of the reciprocal functions in there. So you're going to have to know how to do this. So change it to tan. Tan's on your calculator. Inverse tan this. And you get 0.5880. And tan is positive. Same with cotangent in that first quadrant. And what was the nice little feature about tan? All you have to do is take that answer and add pi to it, and you get your second answer. There we go. Okay, so now just to understand a little bit about the calculator functions, especially with reciprocal functions, we are going to go over some of these things here. So if it says sine of 2.4, 2.4 is in radians, so make sure your mode is in radians and go sine of 2.4, and we get 0.6754. So try that and see if you can get that. I'm going to give you a second to play around with cotangent of 3. So try that. You can pause the video. So you should get -7.0152. So how do you get that? You have to find tan of 3. And I got approximately -0.1452. This is your trig ratio. So what you need to do is you need to reciprocate the trig ratio. There's an actual function on your calculator, is the reciprocal function. It's x to the -1. If you take your answer and reciprocate it using that button, you'll get -7.0152. Okay, so I'm going to give you a second to try C. Okay, and so what you get for that is 14.3355. Okay, so first off, if you didn't get that answer, did you change your mode back to degrees? So that's their first mistake. If you didn't, then you would find sine of 4 degrees, which I found was approximately sorry, 0.0697, blah, 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 and then you reciprocate that to get the cosecant. Okay, so it says using a calculator solve. So first, these questions that have reciprocal function, the first thing that you would do is, if you reciprocate it, you're pretty much guaranteed 1 mark out of this. So that means tan x is equal to -1/4. So my reference angle for x, again, this is in radians, so change your mode back to radians. So I have to inverse tan. Remember, I ignore the sign of negative. So I get the reference angle to be 0.24497. That's your reference angle, not your answer. So then now we need to get it into the second quadrant. So I need to take pi and subtract that. And I get 2.8966. And then I need to get it into the fourth quadrant. So once you have that answer, you can just add pi to that. And I get 6.0382. That's a 2.8 there. All right. Okay, next up. First step, change secant into cos x equals 1/2.5. Find your reference angle. So we're going to inverse cos 1 divided by 2.5. And I get 1.1592. And cos is positive, so that means that is one of your angles. And then where is the other quadrant where cos is positive? Well, that would be the fourth quadrant. So take 2 pi and subtract that. We get 5.1239. All right, last question here. Again, we need to change this into sine of x equals 1/6. Remember, it's the reciprocal trig function. So if the trig ratio is 6, then the reciprocal would be 1/6. So first step, finding my reference angle. So that would be inverse sine of 1 divided by 6. It's approximately 0.1674. And that will be one of my answers because sine is positive there. And then to get the second one, we're going to take pi and subtract the answer. So 2.9741, and that is your answer in your second quadrant.